Hey everyone, welcome to section 4.1. We're going to go all the way back to the beginning of chapter 4 and talk about related rates. Okay, what is a related rate? Well, that's when two variables are changing over time. So I'm going to need some sort of function that will relate to different variables. And you guys know a lot of functions, like A equals pi r squared. That's the area of a circle. What are your two variables here? A and R. It doesn't have to just be two variables. It could be as many variables as you want. But we're going to have some sort of problem that has two variables in it at least. Big concept for today, guys. Since we're taking the derivative of two different variables with respect to time, all of our derivatives are implicit. They're all going to have a d something with it. Every variable, when we do the derivative, is going to have a d something with it. So we're going to draw a picture, and we're going to write down what we know. We're going to write down what we're looking for. We're going to write an equation to relate the variables. This is usually some sort of formula. We're going to take the derivative with respect to t, and everything's going to have a d whatever with it. And then we're going to evaluate. So let's try a problem. Consider a sphere with a radius of 10 centimeters. So, radius is 10 centimeters. Suppose that the radius is changing at an instantaneous rate of 0.1. What is the symbol for how fast the radius is changing? It's dr. So dr is 0.1. At what rate is the volume changing? What's the symbol for changing volume? It's dV. And that's what I don't know. So I need some sort of formula that talks about volume and R. Oh look, they gave it to me. They already gave me the formula for the volume of a sphere. It's 4/3 pi r cubed. Let's take the derivative. Remember, all of these things have to have a d something. What's the derivative of v? dv. What's the derivative of this? Now remember, this is just a number. So let's multiply the 3 down. 4/3 pi times 3 is 4 pi. R squared. And since it's implicit, it needs a dr. Everything will have a d something with it today. Now let's plug in all the stuff we know. I don't know what dv is. That's what I'm trying to find. 4 pi. The r is 10 squared. The dr is 0.1. So dv equals, that's 100 times 0.1 is 10 times, that's 40 pi. Now what are the units? Well, it's volume, so it's centimeters cubed, that's volume, but it's changing every second. So what did I do here? I wrote down what I knew. Anything that's changing is a d. I wrote down what I wanted to find. I found a formula, which they gave to me. I took the derivative, made sure I had d's with everything, dv and dr. I plugged in what I knew, I solved for what I didn't know, and I evaluated with the correct units. Let's try another one. A pebble is dropped into a calm pond. I don't know why there's an extra apostrophe there. Calm pond, causing ripples in the form of concentric circles. So I have circles. That's my ripple. The radius of the outer ripple is increasing at a constant rate of 1 foot per second. What is that telling me? The radius is increasing. So the radius is changing at 1 foot per second. When the radius is 4 feet, what rate is the area changing? So I want to talk about how fast the area is changing. So I wrote down everything I know and what I want to find. This time it doesn't give you an equation. But I need to know an equation that talks about area and radius of a circle. What formula talks about area and radius of a circle? Area of a circle is pi r squared. I have everything I need. Let's take the derivative. What's the derivative of pi r squared? It's 2 pi r. dr. Plug in what you know. I know that dA is equal to 2 pi. R was 4. dr was 1. So dA is equal to 8 pi. Now let's get our units right. It's feet, but it's area, so it's square feet. It's D, so it's per second. Again, I read the problem, I drew a picture. I wrote down what they told me, I wrote down what they wanted me to find. I took what they told me and what I wanted to find, and I came up with a formula based on my picture. I took the derivative with d's in the whole thing, dA and dr. I plugged in the information they told me to find the information that I didn't know. Let's go with the harder one. Given that theta is pi over 4 and that the d theta is 0.14 radians per minute. So what's happening here is the balloon is going up and the angle is getting bigger. How fast is the balloon rising? In other words, what's dH? Well, I know theta and d theta, and I want dH. What sort of equation do I have to relate the angle, that side, and that side? Well, that's the opposite side and the adjacent side. What thing from trig relates an angle to its opposite side and its adjacent side? Tangent. Tangent of theta equals the opposite side over the adjacent side. Notice something. This 500. Is this 500 going to change in this problem? Is the balloon going to go further away? No. So I can just put the 500 in the problem. It's not changing. Okay? Let's take the derivative. What's the derivative of tangent? What's secant squared, theta, d theta. Don't forget, I'm doing implicit differentiation. Over here, if I were to rewrite this as 1 over 500 h, what's the derivative of 1 over 500 h? What's 1 over 500? dh. So I want to know what dh is. dh is equal to 500 d theta over, I don't have a secant button in my calculator, but secant is 1 over cosine squared. Let's plug in everything I know. 500 is 500. D theta was 0.14. Cosine squared of theta was pi over 4, I think. Yep, pi over 4. If you plug all of that into the calculator, you get 140. But I got to use the correct units. 140 feet, because it's the height. And it's D, so it's changing. 140 feet per minute. I did all that in the calculator. I'm assuming you guys can too. Okay? Related rates are tricky problems because you've got to know what sort of formula relates the two things together. Okay? One more example, guys, and it's a tough one. A machine is rolling a metal cylinder under pressure. The radius of the cylinder is decreasing at a constant rate of 0.05. So let's stop right there. I know that dr is negative 0.05 because it's decreasing. I know that the volume is 128 pi. At what rate is the length changing? So I don't know what dH is when R is 2.5. And it tells you that V equals pi R squared H. We have a problem. We have a V, and we have an R, and we have an H. We have 3 variables. I can't do this problem with 3 variables. But let's stop and let's think about this for a second. I have a cylinder, like a tube or a can, and it's rolling, and it's going to get skinnier and longer. But what about the volume? The volume isn't going to change. You don't suddenly have more material just because it's getting longer and skinnier. The volume isn't changing in this problem. The volume, this is a big concept, the volume is constant. Because the volume is constant, there we go, I can go ahead and plug it into the problem. 128 pi equals pi r squared h. Now let's do a little bit of cleanup. Let's cancel the pi's out on both sides. And let's say that 128 over h equals r squared. Now I have an easy formula. Let's take the derivative of both sides. This is negative 128 over h squared dh equals 2r dr. Let's plug in everything we need. Well, let's actually solve. I need dh by itself. So I know that dh is equal to 2r dr times, move that over here, you get h squared over negative 128. So let's plug in what we know. dh is equal to 2. R, it told us in the problem, was 2.5. dr was negative 0.05. But it doesn't tell us what h is. We don't know what h is. So I'm going to come over here and I'm going to find h. The only formula I know is v equals pi r squared h. But I know v is 128 pi. And I know that r is 2.5. So I can find h. I'll do a little bit of arithmetic here, and I'll find that h equals 20.48. Once I know that h equals 20.48, I can plug it back in. So dh equals, if I plug it back in, I get 0.04. What are my units? My units are inches per second. So since this is a multiple choice answer, it's none of these. What made that problem difficult, besides the crazy math? It had a constant in it. The volume does not change throughout that problem. Because of that, it has to stay the same, and I can plug it in before I do the problem. There's going to be a lot of practice on this section. Because of that, if you have any questions, come talk to me. This was just the basics. You're going to need to practice this a lot. There are a lot of problems like this in the AP test, so be comfortable with it. You'll see a lot of it on the chapter test too. As always, guys, any questions, come talk to me. Thank you.